the deep dive it is, then I think without further ado, if I don't know, Z or others, if you have a particular angle you wanted to approach. Yeah.
I mean, my main desire is to see us like testing how these things fit together, but obviously we need to be mutually updated on how the parts work before we can try to connect them. I broadly construed, I'm seeing the kind of interlay as more of a kind of UX, visual surface for connecting things and making that architecture level more legible so that we're making parts and connecting them to each other. And the kind of CoiNet stuff as the place where computation that is being connected together would live. But that's also my bias. So if it turns out that's not the case, then so be it.
Last time we met, we had discussed either going through the current provisional CoiNet protocol to catch up Interlay and then potentially also carrying from them, or kind of doing a deep dive in more of the overlap. So maybe we should decide which of those would be helpful. I'm happy to do like a quick summary in maybe 10 minutes just to catch you guys up to speed, or if there's a better way to start, I'm open to that too.
Yeah, I'd be inclined to do the latter. Like we can do a short-ish overview and then look at overlap, and then we have some time scheduled tomorrow at the same time where we can sync more deeply on the architectural stuff.
Oh, right. I forgot we made that call. Yeah. Okay. So you do want to start with the overview of CoiNet, or did I miss? Okay. Sounds good.
That sounds good. Yeah.
Okay, cool. Run some my screen.
Yeah.
Okay, cool. Yeah, so I'm just going to do a quick overview of the basic node model that we've been working on, and then give you a preview of kind of the first kind of finalized or final draft of the CoiNet protocol. So kind of where it starts. You might have seen this diagram. I sent this a month or two ago. But this is kind of key to understanding the communication patterns across the network. So we have kind of these 4 ways of interacting between nodes. So this top layer is these blue arrows are sort of one-way communication. So this is event streaming. So this would be events are being passed from node to node without any expectation of a response. And then the bottom layer, the red arrows, this is two-way communication. So this is more like client server. This would be I'm asking for something, sending a query, and a response comes back. So broadly, these are kind of split into like an input and output side, which is a little bit of a weird way of looking at it because like some of the output side is pointing inward and some of the input side is pointing outward, but it's from the perspective of how knowledge is flowing through the system. So on the output side, we're broadcasting out events about knowledge. And then on the kind of two-way communication side, we're responding to queries about knowledge. So even though it's receiving a request, kind of the purpose of this type of interface is telling another node about some knowledge. So still kind of consider that an output modality. And then the opposite is on the input side. So we're either listening to receiving events about knowledge or sending out requests about knowledge to another node. So these are kind of split across those 2 dimensions. So this is the input side, output side, one-way, two-way communication. And then the last bit is kind of viewing it in terms of like passive and active. So that's sort of the directions of the arrows leaving or entering the node. So when the arrow is leaving the node, it's indicating active communication. So on the broadcast interface, I'm sending out an event. On the input side, this is sending out a call or a query to another node. So that makes the node the active participant in kind of a node-to-node communication. And then the passive side is flipped. So I'm listening, I'm receiving something, or I'm kind of servicing a query, responding to another node's request.
Yeah, and I really like this, and even Luke and I talked about it yesterday, and I just kind of want to emphasize that from like an event orientation, it really means like either the node is initiating the event sequence or someone outside of the node is initiating the event sequence. So, when you make a call, you're initiating a, potential chain of events with another node. Anyway, I really like it. It took me a while for it to click, so I feel like calling it out, but I think this is a really tight way of thinking about the node's capabilities. And anyway, I'll share that now.
I'll pause for a bit here if there's any questions.
This is all sounding good and making sense.
Let me see if I can bring up, I have one more diagram. This is kind of a larger coordinate pattern. I'm gonna change my screen here. Okay, so this is kind of the first proposed network architecture. One of the things that I'm trying to emphasize with this protocol is that we don't want to prescribe any particular configuration, and we want to actually be able to support a wide range of them. I was talking to Z about this yesterday, but we actually kind of identified a range of configurations from like fully decentralized peer to kind of fully centralized broker-based pub subsystem. So this is the latter. This is kind of a proposed pub subsystem, which I don't think is actually the one that we'll end up implementing for BlockScience, but I think it's a good starting point to understand how the system works.
Oh, and I'd add that the way that you laid those out gives you stuff in between. So you end up with kind of a facilitator model. I like my Deontics. You kind of have the full peer-to-peer, which is very think like you're running a Tor node or something, and you're like, that guy's a leech. Screw it. I'm not going to connect with them. There's no other, you just make your own choices about who you're connecting to. At the other extreme, obviously, what Luke just said about broker-based pub sub, but in between, you get a facilitator thing where you have nodes that you can peer with to help you connect. And that goes back to the kind of telephone operator analogy where you don't actually have to call the telephone operator in this case. It's just an option if you need help connecting to someone whose number you don't know.
Yeah, that's right. So in this kind of example configuration, we have these kind of broad categories of nodes. Again, based on our general diagram, we're not locked into these kind of patterns. It's just kind of a way of helping us understand the role the node is serving in this particular network configuration. So on the left-hand side, we have the sensor array. So this is taking in data kind of from the outside world. So existing platforms, Slack, TrackMD, Google Drive, and kind of normalizing it into internal CoinNet communications using those standard interfaces. So this kind of blue pattern represents the one-way communication. So this is them kind of streaming events in about the knowledge that they're observing into this kind of broker here, which is then streaming those events out to these subscribers. So these nodes right here represent processors. So they're doing knowledge processing. So we can kind of look at one example here. We could consider this maybe a text search system. So this is receiving knowledge events from some of the sensors, and then it's querying the Google Drive sensor node directly to retrieve that knowledge object. And then this processor itself might actually be queried by a node that's kind of further down in the system. This is an actuator. It might be like a user interface where someone's, could be on the KMS BlockScience website where they're typing in a query that gets sent off to the processor node, which then kind of distributes those queries as it needs, depending on whether that knowledge is cached locally or it needs to go out and fetch it from other nodes. So yeah, this is kind of piecing together those nodes, how a larger communication pattern might look in a network. Any questions or thoughts on that?
I love it. Does it make sense?
Can you add, I'm not sure if it's planned for next, but just a brief overview of the idea of proxy nodes and the sort of subnet to subnet peer relationship? I think that's a good place to go.
Okay. We're going to get a little bit meta for a second here then to kind of get into that topic. So one of the things that I'm the most excited about this system is the fact that we can bootstrap the network configuration using knowledge objects and using all this knowledge infrastructure to kind of broadcast and process the meta knowledge of how the network configures itself. So that's a little abstract, but I'll try and make that a little bit clearer and then get to Z's point. So this is kind of still early phases, but these are kind of two potential knowledge objects for network configuration. So this is knowledge about a node and then knowledge about an edge between a node. So these things are both knowledge objects. They're both RID'd, and they can use the exact same infrastructure as all other knowledge. So we can transmit events about them to other nodes. we can have other nodes query other nodes about the state of other nodes or edges between them. And this means that we're not making any like basic assumptions. This is kind of actually like a slightly like a layer above the very basic node pattern. And it also means that we can have nodes, which their role within the system is just to listen to kind of these internal network events and construct an internal view of the network. And I think this would be really cool for like an interlay integration where we could actually have like in like the whiteboard or in the canvas, a visualization of all the nodes and their linkages, and like maybe even be able to reconfigure them.
Yeah, I'm going to keep with some analogies since we're still figuring out how this stuff's going to be implemented. You could sort of think about that like an inner monologue, and then you could have a second, more interface-oriented processor that consumes knowledge objects from it that it makes available, and access controls or gates for sharing with other like orgs or other meta nodes. So like back to, I know, because Orion and I did, very early on, we kind of started off this pitch for Koi in the first place around inter-org communication with the Metagov folks. And this is actually concretely taking us towards, okay, if we have what Luke just said, a kind of node that listens to everything and kind of maintains, for lack of a better term, this inner monologue, and then that thing itself feeds into another processor or kind of proxy or interface node that actually controls kind of what the node says and to whom based on who outside is asking it for information. And so you get that kind of peer-to-peer org-to-org relationship in that architecture without imposing really anything about the architecture, either inside of the organization's KOI or even which other KOIs you talk to, because it's still just other nodes.
Yeah, exactly.
Yeah.
And this is something that David has kind of been pushing for, is like thinking about this in like a fractal-like pattern. So the shape of an individual node is also the shape of a network of nodes, which means that just like how we don't need to worry about the internal structure of how a node operates as long as it has these common interfaces, we also don't need to worry about how a network is configured as long as it has the proper interfaces to communicate with other networks. So that means we could have one network be a very centralized one with like a single pub sub broker, and another network have completely different architecture and be able to communicate without really worrying about that on kind of a network to network level.
One network could literally just have its processors text Jeff, and its entire response pattern could be Jeff texts back. I mean, this is silly, but like, I like, part of what I like about this is if you take these really extreme use cases, if you build the right, like, like in that case, Luke, it might even be like a partial node that was just handling the SMS interfaces. But like Jeff could be a node in a CoinNet.
Yeah. So the last bit I'll share here is just oh, sorry, did you have a thought, Jeff?
Just can't wait to be a node in the KOI net.
Can't wait to have you. Yeah, the last bit I'll share here is just kind of these endpoints. This is taking that abstract node model and trying to put it into something more concrete. So these represent the input and output sides. So the event streaming is done through two methods. So there's a post endpoint on the recipient of an, so that's like a webhook kind of callback. The other option is the event provider has a polling endpoint, which allows for other nodes that don't have to be their own servers to integrate with Koi. And then on the output side, for kind of the internal state, you can query about the RIDs a node knows about, the RID manifests a node knows about, or the bundles, the knowledge objects. So it's pretty simple, but these are kind of sufficient to communicate and propagate events, and also transfer like the internal state of nodes between each other. And then the final endpoint, this is kind of like a special case, but it's necessary to start building a network out of nothing, is a handshake endpoint. So this is just a node queries another node, and it sends its like own kind of profile, its own like meta knowledge object about itself. And then it receives the same thing back from the other node. So two nodes shake hands. Now they know about each other and they can start to communicate and decide if they want to link together. In a more centralized system, there might be a single node that they kind of should handshake with first and then like learn about the rest of the system. But in a peer-to-peer system, they might just need to talk to anyone who's in the network and then go from there. So yeah, I think that's enough for kind of a rough overview. Yeah, hopefully some of that made sense.
That makes a lot of sense. One question I have, which we can definitely get into more detail tomorrow, and it's like almost like a rubric of whether the architecture is successful in my head, or like a small part of it is like whether it can scale all the way down to running like on a single device, right? Like a network on your phone or laptop or whatever. And so one question there is, how baked in is the REST endpoints versus other transport approaches like named pipes or dbus stuff, like more say Unix level OS stuff? Is it not as like a first thing, but is it generic enough to have like multiple transport layers there, or like not really transport layers? I guess it's more like I'll say transport. It's the wrong word for.
Yeah, that's a really interesting question. I mean, so far I've just been thinking about kind of running little mini servers with APIs, but I think that would, yeah, definitely be possible. I mean, I don't think there's anything that's like super required about having it be a REST API, as long as kind of there's only a few number of endpoints, as long as the purposes of those functions match up and the data being transmitted matches up. I don't think there's any reason why we couldn't do that. And then I'll also add that another thing that I'm thinking about is like full nodes versus partial nodes. Let me share my screen again real quick. But this is for supporting the capability of kind of nodes that want to interface with Koi, but don't want to go through the hassle of spinning up like an API server that, either has to have a public endpoint or a local endpoint. So this is actually what the event polling endpoint is for. So if the nodes ideally should support either webhooks or polling as valid methods of transmitting events. So that means that you can have a partial node, which isn't even a server, but it can just call servers that can subscribe to events from other nodes and query state from those nodes. They wouldn't really have a way of of revealing their own state. So that would have to be done through like probably a node proxy or just sending knowledge directly in those events. But we also have those capabilities to add some more flexibility.
Yeah, and I mean, I want to check this assumption that was true 6 months ago, but may have changed. But that, like, in principle, right, someone could take RIDs and build their own, like, very different architecture, doing a bunch of, I don't know, weird database stuff and whatever that is not compatible with Coinets, but the RID part of that would be. So you could have like an internal system to some organization that was very bespoke, very non-interoperable, but still be able to build like an interface layer to other networks.
Yeah. I don't think I actually got to this, but Z had mentioned proxy nodes, which is kind of an idea I had about how to treat networks as nodes, but I think it's also relevant for that question, which is just like you kind of build a single node, which represents like a certain set of knowledge, and you just give it those endpoints to make it compatible with Coinet. But it doesn't mean that the internals of your network have to be compatible. So to take this example of like being agnostic to the inside of things even further, if you build a proxy node, you don't even have to be running any Coinet stuff inside your organization. You can run your own, completely bespoke knowledge management system, as long as you have things that are RIDable and you can build like a proxy way of querying through them. You could build that into a larger inter-org Coinet.
So the one thing I want to add to this that it may not be obvious is that because we're so agnostic to the insides of things, we also, the negative side of that is that like you can interact with something and it could change dramatically or behave erratically without it manifesting obviously through its interfaces, because its interface is preserved. And with that in mind, Luke and I were talking a little bit about what I was thinking of as like norms directly in sort of a node's, I think it's a manifest or its header or the way that it describes itself, so that when we talked through how nodes introduce themselves to each other, it's actually plausible for them to have optionally within their kind of self metadata that they share when they introduce themselves, information about, how they can be expected to behave, what behavior they expect from the party that they're interacting with, basically the agreement or terms or norms under which you would stay linked. And so you can do a sort of weirdly social modality of peering, and this particularly I expect to be salient in the more peer-to-peer or kind of org-to-org architectures where you don't actually have any a priori strong guarantees of the behavior. You just know the interface. So like, yes, you speak English. Yes, you can talk to each other. But like, do I know that you're telling me the truth? Like, how do I actually establish a set of shared expectations about what is good behavior pursuant to like maintaining the link, say, answering your queries or like choosing to route information to you? And so that's obviously a little bit further, but I think it comes up pretty quickly in the sense of like we talked about the proxy nodes, for example. That's the level at which I would expect us to start having like these bits of JSON that are actually like coded as kind of normative expectation setting so that when you do handshakes between nodes that are essentially representative of distinct organizations or kind of political bodies, individuals or groups, that the relationships being forged are actually somewhat stable.
That makes a lot of sense. Just give me and Jeff 90 seconds. A laser cutter is just getting loaded. I'm going to go help carry that.
Christine, I feel like this is like the really hardcore version of dynamics. Remember we talked about dynamic schemas and I was trying to get you like really like dynamic structure pilled? Well, I was just trying to get you excited about something that I was excited about.
No, I mean, it's one of my favorite topics. Like, it's a huge part of why I'm here. So I love that it keeps coming up.
We're back. It was a false alarm. It's actually, unfortunately, just a crate of whiskey.
Sounded like more fun little laser cutter.
I don't know, a 40-watt, like, massive laser cutter? That sounds... I've never been disappointed to have a crate of whiskey arrive, but...
That's good. No, I think it's interesting here because the dynamic schema has the same sort of relationship to, the node is responsible for basically everything. It is responsible for who it connects with. It's responsible for sort of maintaining the normativeness of the information flowing across, and is responsible for disconnecting if things just get weird. So I think this is good.
Yeah, but I also just going back to the meta pattern that we discussed briefly about the something monitoring that creates a sort of internal monologue and then something that has a kind of adjudication, like, do I respond? Do I connect? Should I share this? And so on. You can sort of imagine that there's a duplicate role of that bit of JSON that I was describing as both setting expectations about how I will behave, but also like materially affecting how I will behave in the form of heuristics for whether or what to share or when to respond and so on.
The other thing I want to point out here is like, this is kind of like a layer of protocols. So Ryan, you kind of pointed out, or asking your question about the RIDs, that's kind of at the base layer. CoinNet is like utilizing RIDs and adding some additional like objects and communication standards. But even that, like the particular way that we're organizing our network with like using these CoinNet nodes and CoinNet edges, that is like kind of slightly above the fundamental interface of a general node. And then we're going to have like more stuff that's building on top of that, like security layers. That's going to be a serious problem when we want to do inter-network communication. And then like norms, like Z was talking about like best practices for nodes, or like if we have systems where we're not just dealing with nodes that we build ourselves and we can't necessarily trust them. There might be like a very complex trust layer and negotiation going on. So I think there's going to be a lot of things building on top of it. And I think also not every project is going to be on the same kind of stack going all the way up. So we might find that we have a certain solution for BlockScience's KMS that's kind of compatible up to a certain level, which means that we can kind of cooperate with most or all CoinNets in some ways, but in certain CoinNets in more kind of intimate or like complicated ways.
I sort of expect us to be testing this out by building up from the foundation, right? So you did RID spec, you're going to do coinet spec. We're doing a little bit of like small local coinets where we have control of everything. And then we're kind of moving into local coinets with a kind of facilitator kind of model where we have a helper node that makes sure that our nodes can coordinate with each other, but they can largely trust each other. And then once we ladder up to a view on that, so we have a node that's listening to all of those and starts to create a kind of a reflection of itself, then we can start to look at some analytics and try to understand how our network works. Once we have a little bit of an understanding of how our network works, we can put a kind of proxy interface on it that we use to enforce some stricter access controls and sort of start probing the boundary of how do we make it available, for example, to MetaGov, which is still a trusted party. And then we go up from there to creating interfaces and norms that are suitable for even potentially an open API. But like that open API is extremely restrictive in terms of like when we could expect to respond to it and what we would expect to respond to it with. But like that way we're going all the way up that stack that you just described. And we'll probably learn a lot in the process. But if we're trying to do is enable these big, diverse, self-organizing, kind of growing systems, that last spot is the spot at which the system becomes, or that last stack level is the spot at which you kind of unlock a kind of runaway peer-to-peer network of many organizations with whatever internal architectures they want. David, we might have found your OSIB.
Funny how you're saying that and just dropping. Well, I'm trying to drop. As soon as you can't drop a ping into a Zoom chat. Oh, well, I'll do it on
Screen share.
This is, yeah, I can do that. So 2 years ago, I think it was 2 years ago, Josh, correct me if I'm wrong, I had this sort of an idea pushed at a baccalaureate conference that, from the last 30 years of development, sort of, we figured out how to do this OSIA kind of, the current TCP/IP stack that the internet is based upon, and that, in order to have networks of network computers, we need to work on this OSIB thing. And there was this idea that there was, EVMs would form the processing layer, and then we'd have communications between them. But I think this is even more general than that, because we're not specifying the processing layer hardly at all. There's no specification that it has to be EVMs. It can be basically anything, but we are defining what the stack needs to look like. And it's not CATS that's doing it, but CATS is sort of morphed into COI. So the research that we're doing now is sort of, what does this stack look like? And I think it fits right in with what Luke was saying.
And CATS isn't gone from the vision. I mean, my take is that in this protocol stack, you have CATS or a variant thereof as a provenance protocol that's available for when you need provenance, especially given that a lot of knowledge could be flowing through these networks, potentially long distances. As long as we care about attribution, then we may care about protocols that are capable of maintaining the equivalent of warehouse receipts and shipping manifest evidence, so to speak. And I think what we'll find, back to the discussion of laddering up, is that if we get to the last layer that I described with the, effective inter-organization communication and coordination, possibly the next thing is, how do you maintain provenance so that information that flows through multiple hops, or knowledge that flows through multiple hops, has some reliable information about its kind of the supply chain it flowed through. And I think that brings us right back to CATS.
Yeah. And the idea was always that CATS should be simple. That it was just thought of then as sort of a research tool. What does it take in these layers here to make doing that sort of provenance respecting thing up here at this top level possible? And I think we're going into that in a deep way. That is, Orion pointed out, we can't make guesses, specify unrealistically what this layer, the OSIA layer 7 protocols are. We should be able to adapt to anything. We can't make, specific guesses about what computation is going to look like, what processing is going to look like here. We can't just assume it's going to be, EVMs. So, it is still this area we're looking at, but we sort of brought a lot of it into play in developing this layer architecture, which this is really good. I like it.
One thing that I'll just point out with this stack that I like in the point that you made, David, of like actually getting less specific with that kind of Web3 network computers layer is that we really haven't figured out how to specify the behavior of systems. Like we have lots of methods and type systems and so on to say exactly the shape of some data, but specifying like the internal behavior of something or how that even appears from the outside is at the very least an unsolved problem and quite likely to be unsolvable because of the limits of computable languages and so on.
That's the difference between a computer science problem and an engineering problem. Like an engineering problem presupposes the imperfect ability to assert the behavior of the system that you're making, but allows you to make contextually appropriate kind of axiomatic assumptions and then to like render a system that has situationally appropriate stable behavior, not like infinitely guaranteed stable behavior. And I think part of what we're doing with our other work stream is building out methodologies, tools, and practices for doing exactly that. The thing you said, the ability to assert, to specify, stabilize, and to kind of calibrate, maintain the integrity of the behavior of a system, which is part of the reason why we still have a CRUD plane in Koi, is that you can have a fun plane where systems are effectively peer-to-peer, but the CRUD plane is how whoever is responsible, whoever is the principal to that agent, is going to maybe have to intervene in order to maintain the integrity of that system as against the expected behavior.
I don't know if it's the benefit of being sort of a naive interpreter of language. I'm not a mathematician. I'm especially not a topologist. But I like the concept of a manifold, specifically in that a manifold is defined in such a way that locally it makes sense, whereas it might be really complex globally. And this is the same kind of thing. Locally, these networks make sense, but if you take it too far out, it becomes, it requires some serious abstraction to.
Well, it's better than that the global properties are inherited from the arrangement of simple, locally consistent things. And so what we're doing is figuring out how a set of locally, minimal, locally enforced protocols, policies, rules, structures that when stitched together form something that can be as complex as the world itself and even evolving in time as a result of the decisions individual actors take. But nonetheless, if you hone in at any one point, you have a locally well-defined and navigable thing. And I think that is essentially the essence of the manifold, although we've moved beyond, locally Euclidean space to something, to something else. But we're describing what the locally well-defined means, and we're describing what the connectivity rules between the locally well-defined regions are, but we're preserving all of this flexibility so that what emerges from that has, max variety. We got to get Jeff and Orion.
Yeah. All right. Let's see. How do we structure this? How much have you seen of like the Interlay stuff, Luke and Josh?
It's been a while. I think I saw your demo a couple of months ago.
Months.
I haven't seen
Maybe
it.
longer.
Yeah. I mean, there's too many demos to really go through. So I think we can just kind of keep it a bit more high level. Very, very happy to share stuff later because it's always fun. But maybe the thing to do is I can share my screen and maybe just go through some of the stuff in the memo, which was because I was off when I made that, it was partly made for fun, but it also does summarize some good things. Let's see. If I share my whole screen, can I change it? Let's find out. Can you see, is my screen shared? Yeah. So I think, Luke, you've probably seen like some of these demos and the desktop stuff.
No, I've not seen that.
Well, this, yeah, so like, I'll get to this later, but I mean, this, you can say like, convert to,
Oh, this stuff. Yeah. I've seen these. I've seen these.
yeah, so you could do something like this, for example, and have some limited interoperability with like across application boundaries by using the accessibility APIs, and of course chunks hand on your desktop, which is very important. Not this tab. We use that. Or like, while I'm showing that, I may as well show the other side of this. Maybe you've seen this one of doing something kind of equivalent on a web page. So if you're on like a normal web page that you don't have the ability to rebuild, you can take it and you can turn it into a canvas that you can draw on, and then you can, take it apart. And then if you wanted to say do LLM stuff, you could turn a bullet point list into like an HTML table. You can also like inject dynamic behaviors and stuff. And part of it is just like about increasing kind of end user malleability over systems. So you take an existing system that you can't change and look at the ways that you actually kind of can make changes without, for example, like forking a GitHub repo and rebuilding something from scratch. Because for almost everyone, that's like just not a viable way of changing systems. But yeah, let me hop through some stuff in Memo. I was partly making it just because it was like a fun thing to design. But I just wanted to point to like some of the research that the Interlay stuff is building on, which is like computational media is a big one, which is like an active line of research in a few places. But the idea there is like that we want to have not better tools and systems, like not making like better apps that work differently, but actually changing the kinds of materials that we build software with in the first place. It also borrows a bunch of work from Stephen Cowell on like integration domains, which is part of where the kind of theory of change comes from, I guess, of needing a domain that is dedicated to like integrating software components as opposed to having that in the same place that you construct stuff with. So if you think of it as like analogous to circuit design, designing and building capacitors and resistors and that kind of stuff is separate from building a PCB and figuring out how they're wired together. But in software, those two are really kind of part of the same process, which means we end up with very tightly coupled systems that are really hard to pull apart and redesign or like reappropriate. Part of the most motivation, I think, is kind of nicely captured in this little chart, which is that the application model of software, like pretty definitionally, because of economic constraints, has to just be focused on the most common user needs that apply to the most users, which I think in most cases really means that the vast majority of user needs are not really like accounted for or helped, because it doesn't make economic sense to do so, at least not when you're building tools and systems in the app-based model. And that's a big part of the ideas behind like computational media, is if you give people better materials to work with, then you're kind of designing like for emergence, and you're able to give people more tools to change their systems to their needs and whatnot. The way I kind of think about this is like changing the like topology of applications, right? So if you look at this very minimalistic diagram, you can imagine it as like, we currently build software in kind of these single boxes that function as like both commodities and a way to organize your system. You can give it an icon and a name and put it in your dock and open it. And we tend to have usually just one interface per application. And so you end up with these kinds of silos that don't have a good way of sharing information. And so the idea with the Interlay stuff is to go from this kind of siloed model of apps and to change the topology so that you decouple the interface layer from the underlying software layer. And so you have ways of constructing interfaces that talk to many different apps and systems at once and give people the ability to construct those how they see fit. And so a lot of so that started with a lot of work on kind of canvas, like spatial canvas systems where you can 3D move around, and that has some really nice properties. Like one big one is that when you can like geometrically encapsulate behavior, right? Like for example, you can have a map in a shape, and you can also have a database query. It means that the ways that you connect those together becomes like explicit, as opposed to everything bleeding into the same environment where you very quickly get conflicting behavior and stuff tends to break. That gives you this nice ability to like have multiple people authoring content and behavior and so on, without them trampling on each other. And a lot of the tools that we have now to build interfaces, they really assume that you have like centralized coordination, or at least a lot of coordination between everyone building an interface, because they all have to avoid trampling on each other. And so like all of our tools and systems are really built to help do that, and not so much having like a hodgepodge of different authors contributing their own pieces. Also, just for historical context, I guess, all of this work originally came out of wanting to have better interfaces for querying and interacting with like KOI data, and like especially graph shaped stuff where you don't know the internal structure of the data, which is just not a problem that existing UI frameworks and stuff are built to solve. They're really built to solve systems where you have a low number of schemas, like an Amazon store page. Like they know that it's going to have a title and a price and a person who posted it, and so you can figure out exactly where you want to put everything on screen, and that's relatively simple. But part of the point of the KOI work is that we don't know as much as we could otherwise assume, and so we need interfaces that are like more adaptable to the data rather than kind of locking down the structure of the data to the interface that we want to build for it. Maybe I'll pause there. I don't know how much sense that's making.
I mean, it makes sense to me. I think one way that I would tie this back into the previous presentations is that we have a bunch of like lower level protocols that make it possible to build stuff and arrange it in a more distributed, even decentralized way, but we don't necessarily have interfaces or common development modalities that complement that. And so what you're presenting here is basically both the thesis for, and you're developing tools for building essentially the anti-apps, the things that manifest or are experienced like apps for people when their internet looks like the OSIB thing that we were just talking about. So taking it all the way to not just developers, but like serving the developers, developing the things that people would then use in a world that was characterized by these data supply chains, KOI nets, knowledge networks things, as opposed to characterized by an existing walled garden, walled city architecture. Is that correct? Because I'm also just projecting. That's what I want it to be.
I like that. Yeah, let's see here. So that's kind of where what started this project, and a lot of the earlier work was building on a library called TLDraw, which kind of made it a lot easier to build spatial canvas stuff. And I think there's a bunch of properties of spatial canvases that we can maybe get into another time that I think make it really amenable to this kind of project. But it's also like not the thing that you need all of the time. And it works better for some people than others. Like some people don't want to have to move around and they just want like a thing that you can scroll through and so on. And on top of that, TLDraw is a not entirely open source library. And it's also really built for building like spatial canvas apps and tools and that kind of stuff, which is ultimately at odds with the kind of direction that we want to take this. And so a few months ago, with the help of another guy, Chris Shank, we've started building an alternative, which we've been calling Folk Canvas. which takes a very radically different approach, and it's built on top of really just very plain web standards. So instead of being this really massive React library, it's built on just like DOM and HTML and JavaScript standards that are in every browser that everyone has. Let me see. Can you still see my screen?
Yep.
Yep. Okay.
Just a bunch of squares with a circle around it.
Oh yeah, this is I may as well show you this. This was just another fun gesture recognition system, so you can like, do stuff like that, draw symbols, or like make boxes by drawing boxes, or tick stuff off by drawing a tick. We'll get back to that. Or this one, which I'm only showing just because it looks pretty. It's doing like global illumination stuff, but this one's actually doing it on top of HTML, so you can make your documents glow if you want to. Obviously, this is a very important key to this whole project. So yeah, the folk canvas stuff is really trying to like strip things way down to the basic building blocks of this kind of approach to building interfaces. So like this is, if I open up my elements here, this really is just like a plain HTML document with like some inputs and paragraphs and stuff. But we're able to treat it as if it were a spatial canvas, even without any custom elements in this case. And so we can take really any website and we can give it the same affordances that we had in the previous system. Or more importantly, this is looking at some projection stuff. Where's the one I want? We also have this programming model called scoped propagators, which you might have come across. I'm not sure if I tried it. Where's a good example of this? Let me see. Do something like this. So it's a really simple event-driven programming model, which I won't go into now, but it lets you take existing UI elements and wire them up without them having to like give you any hooks or affordances to do so. So part of the motivation here is that we want to be able to bring KOI into like more adversarial environments. Adversarial in the sense of you want to be able to adapt existing interfaces in a way that is potentially against the interests of the producers of those systems. So like I think actually if you use Zotero and his browser extension, that's actually quite a good example of this, where you could be on, for example, a publisher's website that does not expose any APIs for accessing like structured information, or at least not free ones. And it will basically scrape structured data off of the page so that you can have good citations and stuff. So this is kind of...
quick thought on that, if I could jump in.
Yeah, go for it.
I was talking to Z about this yesterday in terms of making Koi compatible with existing infrastructure. Because, I mean, the point of Koi is like knowledge management and sharing. But a big part of that is a lot of our knowledge lives in these like walled gardens.
Yep.
Like all of our knowledge sources right now, like Slack, Google Drive, HackMD, exist on like centralized platforms. And so I think this kind of line of thinking is like super relevant for Koi, because one of the things that we can do with that is like build adapters or ways of accessing these walled systems, and then like piping those into like a common interface so that they can flow freely into the rest of the network.
Yeah, that's a really big motivation behind this, right? Is that like and it's also that there's like this observation in this that in some ways doing the kind of crude stuff like what Zotero does through scraping web pages actually has a robustness property that like the more traditionally robust APIs don't, which is that for as long as you have access on the web to those systems, it means you have a structured programmatic interface to get data out of them. And you saw this with Twitter, for example, where like some people have built extensions that would just take the structure of the page and do stuff with it, and other people did similar things using like the Twitter APIs. And then as soon as the APIs got really expensive, all of the systems that were using those APIs basically broke and mostly became unmaintained. but all the ones that were using the slightly scrappier approach of reappropriating the interface affordances, it's a lot harder to take away, right? Similarly, with that desktop demo, it's a similar kind of idea where because you're using accessibility APIs, it's way harder for software providers to justify like removing accessibility APIs, even if they have this other affordance of being able to extract or like insert certain amounts of data. And so, yeah, we want to be able to support like more in situ knowledge organization, right? Where like, which in this case is mostly focused on the web because that's where most stuff is nowadays, but to a lesser extent, and hopefully down the line a greater extent, this stuff should also be able to work like on your desktop and you know not require the web in the same way. So yeah, like this programming model is a really simple one. So I mean, this is just wiring up some behavior to like, you know, make QR codes. But the important part here is really just that none of these components, like this little color picker thing and this slider and this text input, I mean, for one, they're all vanilla HTML pieces, which is also partly why they look like they come from the 2000s. But they're also like, there is no coupling between them in those elements. So you could take any of these elements and put them anywhere else, like it's just normal HTML stuff. And the kind of integration of these components is something that happens on top and outside them, which is really nice because you can also do this for, you know, like elsewhere on the web. If you had I don't know, like if you were on like the ACM site and you had the ability to search papers, you could take one of these propagators and, you know, extract out all of the results of that search with whatever information is visible to you without needing to go through their APIs and stuff like that. Yeah, I mean, a part of this, let's see, is also like being able to, I'll just show you this one just because it looks pretty. I don't have time to go into much of this. You might have seen this one before, but there's this constraint that you often have with like when you're querying large amounts of data and you want to be able to see it, like you can't in practice, like there's a limit just to how much you can see at once. And often we solve that by creating a lot of like discrete views, like you have a list of search results and then you can click in to like see more content and stuff. And so we've also been exploring like a continuous spectrum, being able to have like local effects for being able to like, you know, take potentially thousands of items and view them topologically while you take just a few and you look a little bit closer. I mean, this is quite specific to graph-based stuff in the case of this demo, but the idea behind it is a much more general one. I'm sort of, yeah, go ahead.
I got to do a transition because a bunch of us have to go to Octopus's presentation in Econ. But noting that what you've done here is like started to lean into the consequences of having like a more manifold like model of the underlying substrate. And so this is like, you know, rather than saying, aha, we can do this, like this is a thing we can do because we've embraced that. And there's many other things that you could potentially do by embracing the kind of manifoldiness of the underlying substrate. Anyway, but I'm going to also have to bounce. I know there's a bunch of cool demos. I always a little jealous. These toys are fun. I do actually kind of want to invite everyone to hop over because Octopus is an awesome kind of math teacher / modeler, and he's going to be going over some cool stuff on more of the engineering design analysis side.
Yep.
See you there.
Well, thanks all.
See you, David.
Okay.